All right, let's get into it. Today, we're going to pull back the curtain on something pretty amazing in tech, how you actually teach an AI a brand new skill. We're going on a little journey, using the fantastic tools from Hugging Face to see exactly how this whole thing works.
You're probably wondered about this, right? I mean, how do you take an AI that knows a bit of everything and just make it an expert in one specific thing? That's the nut we're going to crack today. We're going to watch a digital apprentice become a true master.
Okay, so let's set the stage. Every good story has a hero, right? Well, in our story, the hero is this powerful, pre-trained language model. It's already read like a huge chunk of the internet, so it gets language. But it's not a specialist. Not yet.
And this comparison here, it just lays out the whole journey perfectly. On the left, you've got the apprentice, our pre-trained model. Think of it like a super smart new college grad. You know, tons of general knowledge, really bright, but not quite ready for a specialized job. Our goal, this process we call fine-tuning, is to turn it into the master on the right. A total expert, tailor-made to be awesome at the one job we need it to do.
So, how does our apprentice even start its training? Well, it all begins with data. For an AI, data is everything. It's the textbooks, it's the instruction manuals, it's the life experience. But before the model can learn a single thing, we've got to get that data wrangled and ready.
And this is where we hit our first, and let me tell you, it's a huge hurdle. The sheer size of the data. We are not talking about a couple of Word docs here. Like the folks at Hugging Face point out, working with multi-gigabyte datasets is just normal now. And frankly, that's often putting it mildly.
To really put that into perspective for you, there's a data set out there called the pile. It's used to train some of the big models you've heard of, and it is 825 gigabytes. That's way bigger than the hard drive in most people's laptops. You can't just load all of that into your computer's memory. No way. Your computer would just give up.
So what do you do? Well, the Hugging Face library has a couple of really clever solutions. First up is memory mapping. The analogy here is perfect. It's like reading a book from the library without having to memorize the entire library first. You just access what you need directly from the hard drive, your shelf, without loading it all into your RAM, your brain. Then there's streaming. This is exactly like streaming a movie. You don't download the whole thing first, right? You just process the data as it comes in, bit by bit. Genius.
Okay, so once we can actually access the data, we have to prep it. First, we tokenize it. That's just a fancy word for turning text into numbers that the model can understand. Then, for certain jobs, like figuring out if two sentences mean the same thing, we have to put them together in a very specific format. But here's where the real efficiency magic comes in. Using batched equals true lets us process data in big chunks, and that gives us a massive speed boost. We're talking up to 30 times faster. And dynamic padding is another lifesaver. It saves a ton of compute power by not forcing every single sentence to be as long as the absolute longest one in the whole dataset.
All right, our data is prepped, it's ready to go. Now, it is time for the main event, the training loop. This is the real study session. This is where our model actually starts digging into that data and learning.
Now, Hugging Face gives us two main ways to go about this. You can use the Trainer API, which is kind of like taking an all-inclusive guided tour. You know, it's high level, it's automated, it does most of the heavy lifting for you. It's great. But if you're a control freak, and sometimes you need to be, you can write a manual training loop yourself. That's like building your own travel itinerary from the ground up, controlling every single detail.
So what's actually going on inside that loop? Well, it's this really simple four-step dance that just repeats thousands and thousands of times. Step 1, the forward pass. The model looks at some data and makes a guess. Step 2, we calculate the loss, which is basically us telling the model how wrong its guess was. Step 3, the backward pass, is where the magic happens. We figure out exactly which internal knobs inside the model we need to tweak to be less wrong next time. And step 4, the optimizer step. We actually go ahead and turn those knobs. That's it. Guess, check, adjust, repeat.
So, after all that studying, after all those loops, it's time to see how our model did. Did it actually learn anything? We have to give it a final exam, check its report card, and see what grade it gets.
And our #1 tool for this is the learning curve. And it really is. It's a visual report card.
It's a chart that shows us how the model's performance changed over the whole training process. Is the grade going up steadily? Did it hit a wall and stop learning? The shape of this curve tells us everything we need to know. It's how we diagnose if things are going well or if we have a problem.
And the most common problem, the biggest trap we're looking for, is called overfitting. The cramming for a test analogy is perfect. This is when the model doesn't actually learn the material, it just memorizes the answers in the study guide, the training data. So yeah, it gets an A+ on the practice questions it's already seen, but then it completely bombs the real exam, our validation set, because it can't handle new questions.
So how do you spot this? The classic symptom is when your model score on the training data keeps getting better and better, but its score on new, unseen data starts to get worse. You see this big growing gap between its performance on the practice test and the real test. The good news is we can fix it. One simple solution is early stopping. You just stop training as soon as its performance on new data stops getting better. You can also use regularization, which is basically a set of anti-cramming rules that force the model to generalize instead of just memorizing.
Okay, so our model has been trained. It's passed its exams. It avoided the overfitting trap. It is now a master of its new skill. The final and super important step is to share it with the world so other people can actually use it.
And the way we do this responsibly with something called a model card. Honestly, the best way to think of this is as a resume for your AI. It's one document that tells everyone what the model is, what it does, how it was trained, and, this is critical, what its limits are. It's all about being transparent and responsible.
And look, this isn't just some nice little extra thing to do. As Hugging Face says right here, the model card is arguably as important as the model itself. I mean, think about that. It's what lets other people reproduce your work, understand its biases, and build on it safely. It's crucial.
So what's on this AI resume? Well, pretty much everything you'd want to know. A description of the model itself, what it was built for, and what it wasn't built for. The exact data it learned from. The step-by-step training process, and of course, its final report card, the evaluation results.
And you know the best part? Hugging Face makes this part incredibly easy. You can run one simple command, trainer.push-to-hub, and it'll upload your model, its tokenizer, and even create a template for that all-important model card automatically. It just makes it easy to do the right thing.
So there you have it, from a generalist apprentice to a specialized master, complete with a resume ready to go out into the world. We've seen how to handle insane amounts of data, how to run the training, how to check the results. So the only question left is, now that you know how it's done, what's the first skill you would teach an AI? Thanks for joining me on this explainer.